dialysis tubing lab. We made 5 model cells containing 20 milliliters of glucose solutions, and 2 that contained just water, and 3 had actually glucose in with the water. And we put them in different concentrations. So there was a 20% concentration of glucose, a 50%, and an 80%. And it's in the table right here.
Yeah.
Explain that.
Yeah. So basically, here's an isotonic setup. So they're both the same. They both have water. So you would expect to see a change there, and we didn't. These 3 we have glucose solutions in the cell, and then just the beaker solutions are just water. And for setup E, that's our last cell, we have 80% glucose in the beaker solution and just water inside the cell. So we're looking at how these differences in concentration inside and outside the cell affect how fast water diffuses through the cell membrane.
So how we measured that was over half an hour. We took different measurements of the mass every 10 minutes to get our data. Are you explaining? What? Okay, I'll just do it then. Do molecules diffuse through the cell membrane? Yes, but we didn't find evidence for all of them diffusing. We knew this because the mass changed in the different cells. So there's a change in mass, both increase and decrease in the cells. So does water or glucose diffuse through the cell membranes? Water did definitely go through the cell membrane, but there's no evidence supporting or going against glucose traveling through the cell membrane. There really wasn't anything, but on the slide. So evidence, water diffused out of cell E. We'll show that in the graph in a second. Water diffused into cell C and D. So that was the one with I guess 30% and 50% glucose inside the cell. Cell E had water in the cell and 80% glucose outside of the cell. And cell B shouldn't have diffused as much as it did, but there's a leak in the cell membrane in the dialysis tubing, so the data was incorrect at that point. So here's the graph, and as you can see, it shows the change in mass, and the mass of cell D went up the most, as expected, then cell C went up the second most, which was also expected, and then B should have gone up, but because of the leak, it stayed the same, right with A, which is the red one, and then E went down as expected because of the water coming out. So this is the rates of diffusion over concentration of syrup. This graph can be used as to predict the rate of diffusion, kind of like last year when we were doing the shear contents lab. You can go over and find you can find the concentration of syrup, and you can see where it hits the line, and then you can see the rate of diffusion.
Right, and the concentration of syrup is the difference between the inside and the outside of the cell. So for example, for setup E, we have negative 80%, and that's where the blue dot is there on the bottom left. So you can see the rate you would get for that.
And this is the equation of the line. And you can plug in for x the concentration of syrup, and y will equal the change in mass over 10 minutes. So, yeah. Thank you.
me was 80% glucose outside the cell and 0% inside the cell. So why are you not sure that you have evidence that glucose can't go through the membrane?
There's water inside the cell. There was 100% water inside the cell.
Yep.
And 80% outside, 80% glucose outside of the cell.
Yep.
So water did go out, but there's no evidence of glucose going in. There's
Right,
just
so you have
glucose.
evidence that it can't go in then.
Yeah, I guess so. I didn't make that slide, so.
But right, don't you have
Yes.
evidence that it can't go through?
Yes.
So you guys, this is not a cell though, right?
This is not a cell. This is dialysis tubing. which
Right, so the
represents
dialysis tubing has specific size holes, right? So that it was determined that the glucose could not go through based on that. So then why, so can you just tell us a little bit more about why those rates exist and why you think that's like, these lines make sense or don't make sense? So like why is it, I think Ben, you were talking about different percentages and then what you were looking for those percentages. So can you tell them a little bit more about that?
Well, we predicted, if you go to this graph, this mathematical model kind of shows you that the higher the difference that you have in the concentration of glucose solutions inside and outside the cell, the higher that difference in percentage, the higher a rate of diffusion you're going to get.
And why does that make sense?
Because the water needs to travel faster it wants to travel faster to balance it out.
High concentration.
Yeah.
to reach an isotope.